Hello, and welcome to a multi-factor analysis of variance on Minitab 17. Over here on the left, I have the data that we're interested in looking at, the direct mail 15, as we want to see whether or not the factor of which type of so we talked briefly about this data in our notes, and this is a credit card, and we're looking at the total charges of an individual based on different offers that they received and what their spending habits are. So think about total charges in the next 3 months as like their spending habits. And then here I have group recordings, envelopes, and miles. So in miles, we have three options: no offer, double miles, or use anywhere miles. And then envelope, they were either given a standard envelope or a new logo. And what we want to investigate is which of these two factors made a significant difference, or which level amongst the factors made a big difference, or was there a combination of factors that made a difference in what we're seeing as far as people's spending habits? Or is there a specific offer I can give that will cause people to purchase more? All right. So first we want to check some of our requirements by making some box plots of our data to see if we meet the equal variance assumption. So I'm going to go up to graph and then down to box plot. And I want to choose with groups since I definitely am grouping by two different variables here. I'm going to go ahead and hit OK. And I need to give it a variable to graph. We're interested in total charges, and it's grouped in two different ways, by envelopes and miles. Whichever grouping variable, notice how it says outermost first, it starts grouping first by that first variable and then by the second one. We'll see what this looks like after I hit OK. She's running slow today. Come on. There we go. So as you can see, it grouped according to the first thing I gave it, which is envelopes, and then within those groups it created the double miles logo and use anywhere. And these are fairly close. I'm hoping you notice that double miles looks pretty similar to itself across logo and standard, and the same thing with offer and use anywhere. These are all fairly close to each other. I'm going to say that it looks like I can be okay with equal variance. However, it looks like it's better within groups than it does between the groups. So let's see. Equal variance looks to be satisfied. However, it is stronger between, I would say, envelope than miles. Because the mileage groups do look slightly different. Okay. The last thing we want to note is that it looks like one of my groups does have some outliers in it, but they're all smushed close to that minimum. They're not hugely, so they're not outliers that are like way up here. They're so close that it looks like it's probably going to be okay. I also have them only in one group, so I'm going to just go ahead and ignore those and pretend like they're not that big of a deal. So there are also a few outliers because we should make note of them. But they are not far enough from our data to be concerning. Okay, next up we're going to write our null hypotheses, and there are three. Believe it or not, when you do an ANOVA with multiple factors, you end up with multiple hypotheses. Now for the Santa joke. I wish it was winter. If you're viewing this in winter, feel Santa-y about this, your hypothesis set. Okay, so the first thing to note is I have a hypothesis for every single factor and then the interaction factor. So my first hypothesis is going to be that the mean total charges is the same for both the logo and standard envelopes. AKA envelope has no effect. The next one I'm going to say the mean total charges are the same for all mileage offers. I'm going to say miles instead of miles. Mileage. Oh my gosh, miles offers. So the idea being that no matter which mileage offer the individual received, their spending habits didn't change. The last thing I want to talk about is or the last hypothesis I want, where's my mouse, is in reference to their interaction. So I would say the choice of envelope creates the same mean total charges. Keep missing that R. Across all levels of miles. So if you're following along, then I'm saying that envelope has no effect, mile has no effect, their interaction has no effect. So that's what the nulls are for this. And we're going to see all three. All right, so next we're going to do the general linear model for the ANOVA. So in order to do that, we're going to go up to Stat, down to the ANOVA, down to general linear model, and then fit general linear model. There are options on how you can do this for other things as well. If you want to look at the analysis of variance or maybe the balanced ANOVA, it's fine. I'm sorry, analysis of means. I said the wrong one. We want the general linear one because I like this one. It has the most options. So I'm going to put in total charges and then my two factors. Notice these two factors are my individual factors, so they go with my first two nulls, and I need to create an interactor for the last one. Before I do that, though, I'm going to ask it to give me some graphs so that I can check the nearly normal condition. That should be good. Actually, I'm going to change this to standardized. All right. I bet you the histogram for this is going to look awful. Anyway. I just accidentally turned down my sound. Oh, can you hear me now? All right, so next up, I also want to create that interactor term. So here's how you do that in Minitab 17. So to do this, we have to hit on the Models button. And then we highlight the variables we want to combine into an interaction and ask me how you want the order of interactions. We're just going to want 2 because that'll create this times that, envelope times miles, that's 2. I'm going to click Add, and notice it shows up down below. That's going to tell it I do want the interactor present in my model. I'm going to hit OK. And then I'm going to hit OK again to produce the output. You will notice in number 5 I'm asking to create an interaction part. You can do that after you created the general linear model. Let's go ahead and hit OK. This will take a little bit because my computer has been running slow today. I hit OK, and there it goes. Graph, 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 graph. Yeah, lots of them. So my first note is that, oh my gosh, this looks super skewed. I've definitely got those outliers popping up, and I bet you that's where that's coming from. But just to be safe, let's check the normal plot, because the histogram usually isn't the easiest to tell whether it's got normality. This usually does a better job. Oh my, okay. Not great. Sorry if I sound so shocked. Yay! There appears to be something going on here. This definitely fails normality, but it only does it for like the lower 6%. So anything below the 6th percentile has massive failure, and anything above the 99th. So it's not that much area, or it's not a huge range of values where this is failing. It just appears to be really bad for those, and that's why it looks like this. So I'm going to go ahead and say that this is nearly normal, but has non-normality below, I didn't need a comma there, sorry, the 5th percentile and above the 99th. The next thing we should check is independence / random. And this would be in how the data is collected. And it was collected via random direct mailings. And this is actually a completely random design, since they were randomly assigned envelopes and they were randomly assigned mileage. So since everything was assigned randomly, It's completely random. Lastly, I'm going to make note that we did equal variance earlier. Box plots. Okay. I don't know why this is there. It doesn't need to be. Alrighty. So I seem to be pretty good there. I'll do our interaction part in a minute. This actually really should be later. Shrink those graphs because I don't need them. I want to go up. Oh, there's quite a few unusual measurements in here. That's a little scary. Must be all those outliers. Or not, or maybe my model is doing a terrible job. Mental note, next time uncheck that box. Oh no. Okay, so I'm going to make this just a little bit bigger, if it'll let me. Oh well. Anyway, here is my analysis of variance, which I need. I'm going to copy that over to Word. This is going so well. And I'm going to put it down here because that's where I'm going to be drawing my conclusion. And I'm going to paste it in such a way that it shows up with a bunch of numbers for no reason. And super happy that Word likes to number stuff for no reason. Come on. It's still doing it. This annoys me to no end. I'm sure you guys are enjoying that. There we go. Oh, my p-values did not fit. Hold on, let me make this a little bit smaller in text. There we go. That's a little bit more legible. Okay, so the first thing I look is my f values. Ooh, good, good. That's bad. Good, good. Ew, for p-value. So I hopefully am looking at this and being like, okay, clearly envelope and miles are significant contributors, but when combined together, they are not. Okay, so I'm going to have to make note of that in my conclusion. I want to do my interaction chart to see if this is true. So we're going to do this last step with the interaction plot. I said chart earlier. It's a plot. So we go back to stat. Where is it? Anova. And then down to interaction plot. It's down at the bottom. Sorry, for a minute I forgot where this was. I want to do total charges versus my two factors, envelope and miles. I'm actually not going to mess with any of the other settings with this. If you want, you can take a click and look at the options about what title and scale you want, but that really doesn't matter. This is just going to make an interaction graph for you. Oh, fun fact before you hit OK, if you put this in the opposite order, yes, that does matter. Okay, just so you know. It'll change these based on what you're up to. We'll hit OK. And remember, what we're looking for here is parallel lines. This looks parallel, this looks parallel, this looks parallel, this looks parallel. Okay, but what this does tell us, though, is that the use anywhere miles in general are much higher than everyone else. The no offer seems to be performing the worst out of all of them, with double offer taking a middle seat to everything. So it appears use anywhere has a larger effect. And since logo is always above, the logo envelope did produce better results. So let's draw our conclusion. Alrighty. I paused so that I could type this all up because there's no point in waiting you all waiting while I type things. So as we saw already, I have large F values for both miles and envelopes, so those will be rejected. However, their combination is not rejected. So that means that when I look at mean total charges, the difference miles options are significant at the 5% level. I wrote mean total cost here, sorry. And then the same for the logo options. The next thing we notice is that the interaction term is a small f, so we're going to fail to reject here. So it appears that there is evidence that at least one factor for envelopes has a greater effect on the level of miles than the other at the 5% level. And then to see this effect, we're going to actually perform an ad hoc test. Do a comparison to see which of these groupings might be the best. So we're going to go up to stat, down to the ANOVA, and then general linear model, and then comparisons. This is the Tukey test, so it's set up to do pairwise. I'm going to tell it which ones I want to use. So right now it's set to do envelope and miles, but I want to compare levels across envelopes and miles combined. So I'm going to look at the interaction of these two to see who creates the biggest difference. And then I'm going to hit OK. Alrighty. So, this is quite interesting. So, as you're looking at this, what we're looking for is there a big difference when I compare them against each other? And I look at this and I notice in particular that only a couple of them seem to be touching zero. So that means there is a combination within here that's definitely going to create a significance difference here in total charges that people do. Let's see what the groupings look like. Oh, good. So I do have some individuals. Wow, we have a lot of individuals across these groupings. So lots of different behaviors happening here with only a couple similarities. So since these share a letter C, the standard use anywhere is very similar to logo no offer. And then since these two share a letter, we also can say that logo no offer is similar to standard double miles. However, it appears that logo use anywhere, logo double miles behaves differently, and standard no offer behaves the worst. So, fancier envelope does make a huge difference because if you notice, all these logos are near the top, and use anywhere miles definitely beats out everybody else. So, overall, my general recommendation is if you wanted to increase spending, you should always use the logo, especially if the logo is cheap to manufacture and add to your envelopes. And the other thing is either use anywhere or double miles appears to be perform the best out of these groups. So increases spending the most. Anyway, um, that's all I have for you. Oh, I almost didn't say this. I almost forgot. So the other offer thing is like, notice that logo no offer works just as good as standard use anywhere. So what's interesting about that is if you wanted to hit more people, and not cost yourself so much, just the presence of the logo would be cheap, and then you wouldn't have to give away mileage, which is interesting. So you kind of have to weigh your pros and cons. You should definitely consider your costs of offering mileage before you make any final decisions on this. That's all I have for you for today. Tuki, tuki, tuki.